describing motion around us, and in this video we are going to do the topic describing position. So let us see. Describing position. How do we describe the position of an object? So we can describe the position of an object with a reference point. This is our reference point. It can go here, here, or even in the z-axis here. For that, as you learned earlier, we first need to specify fixed point. So we need to specify this fixed point, and we're going to call this fixed point the reference point. So this is the reference point, the distance and direction of the object with respect to the reference point. So the distance and direction, so let us first draw our line, and this is our reference point. So any position which is described, any position such as this position or this needs to be described with direction, distance and direction along with respect to the reference point at any instant. So first you need to tell the distance, that it is 3 meters away, 4 meters away, and also its direction. It can be here or here. This is also 3 meters and this is also 3 meters. So we need to define its direction also, whether it's here or here, right or left. Describes the position of the object at that instant. So we described its position. Note that apart from the distance, we also specify the direction from the reference point, direction right or left, in which the object is located to describe its position. But when do we say that an object is in motion? Now we need to see about motion, as the chapter name suggests, describing motion around us. So when can we say that it is in motion? We can say that it is in motion if its position changes. So let us imagine that at 1 seconds it was 3 meters away, at 2 seconds it was 6 meters away, at 3 seconds it was again 3 meters, 4th second it was 0 meters. As you can see that this position is changing. First goes here, then here, then here, and then here. So it's in motion. Its position is changing with the respect of a reference point. This is important. So let me tell you a story. Imagine that you and me and you are sitting in a car, right? So this is our car, this is me, and this is you. Now if someone asks me in a phone call, is your is are you is your friend sitting in the car, is he still? And I will say yes, he is sitting very comfortably in his car, in our car. Now let us imagine there is a policeman. He is watching from here using his binoculars, and what he will say in a phone call: no, the person who is sitting at the back is not at rest, he is moving along with the car. So it is all just a change of reference point. It's all dependent on reference point. According to this policeman, you are not sitting, and according to me you are still, right? So I hope you get the idea. The object is said to be in motion. On the other hand, the object is said to be rest. Now let us imagine that you're standing here and I'm also watching you standing here, right? And you're just standing here. Then you are at rest because you're not changing your position. You're not going here, here or here. You're just standing here. So now you are at rest because your position is not changing. At rest if the position with respect to the reference point does not change with time, right? So now moving on, describing position. Let us take the example of an athlete running on a straight track. So this is our straight track, this number line. So she starts running from here. To describe the position of Nina, this is Nina, an athlete. let us take her starting point as the reference point. So this is her reference point as shown in figure 4.3. This is the figure. Let us make a straight line. This is the straight line with distances marked on it. So this is 20 meters, 40 meters, 60 meters. These are the distances marked on it, and it starts with the origin, and it starts with the origin O. This is the origin. The athlete starts running from O, and then she starts running from here and goes on. And her positions at two instants of time are marked by points B and A. So this is point B and this is point A. So at some point she was here, and some at some other point, at some other time instant of time, she was here at A. Right, so she's not still, her position was here and then here, so we can say that she is in motion. Right, so this is how we represent points on a position, position line graph. Now let us see one more, the last slide. To describe the position of an object, we also need to specify its direction. We also specify its direction, that whether it is in the right side, right, or whether it is in the left, whether it is in the upward, whether it is downwards, whether it is backwards, or whether is it forward. We all we also need to specify the direction. For the object moving in a straight line like this, the object can move only in one of the two directions, left and right. It can only move in left or right direction. So the right is often taken as positive, forward and backward. So this is forward, this is forward, and this is backward. So the positive, the forward is taken as plus, and the left side, backward, is taken as negative, minus. Positions to the right to the reference point are generally taken as positive, and that to the taken as left as negative, and this is negative. So this is it in describing position, and now we have seen how to describe position. So thank you.